Okay, so we were on. I gave you guys time at the end to work on this one, and then we didn't really have time to go through it. So let's start with that. So part A asks for the equation of the tangent line to the original graph, which is a little bit strange because we can't see the original graph. So they give us this point on it, 3, 1. And then notice that 3, 1 is not on this graph. This graph is not the original because this graph is the derivative. So we're trying to find, it's like 3, 1 is like the point P that we drew those things through yesterday, like they're giving you kind of an original point. And then we want the equation of the tangent line, so here's your x value, your y value, and then what goes here is always the slope. And the slope comes from the derivative. So, but I don't take the slope of this graph. If I took the slope of this graph, what level would I be at? I'd be at f double prime. So I want to know the slope. I'm looking at a graph that tells me the slope, so I just read the y value off of this graph. So I go to 3, read up, and the derivative when x equals 3 is 2, which means the x value, or the slope when x equals 3 is 2. And then that's your equation of the tangent line. So there's no need, this is a pure response, there's no need to simplify. If you did, it'd be like 2x minus 5, but you're only taking a risk if you keep going because you might like add wrong or something. So I would just stop right there. Okay. Does that make sense?
Yes.
Part B, where does that have a local min? So the original graph is doing what during all of this? Decreasing y. The derivative is negative, or the derivative is below the x-axis. And then we go here where the derivative is above. So the original is increasing. So at x equals 1, the original switches from decreasing to increasing. So at x equals 1, since f prime changes from, be careful, don't put decreasing to increasing. Because if you start talking about the derivative decreasing, now you're actually taking the slope of the derivative and you're getting to the second derivative level. So it's because it changes from negative to positive or below the axis to above the axis. Yeah, what's up, Ethan?
Nope, I'm good.
Okay. Estimate f double prime of 2. So 2 is right here. That's the point. If I asked you to estimate f prime of 2, you would read off the y value because we're looking at the f prime graph. But I want to go a level below. So how do I take the derivative of a graph? Look at the slope of it. So your job is to estimate the slope of this at x equals 2. And they're pretty generous with it. So you're kind of trying to estimate the slope of that like surfboard that we've talked about before. So to me that looks pretty close to a half. It's almost like you're going up 1 over 2 based on those boxes right there, you know. I think they'd probably accept 1. They would not accept 0. It's like it's obviously not flat there. And they wouldn't accept a negative number. And they might accept 1. I don't know if they'd go as far as like 2, but you see where I'm getting a half from? A third, a fourth, 2/3. I mean, anything around there. It's hard to tell exactly. But. Alright, part D, where does f have an inflection point? And explain briefly. Well, inflection points come from the second derivative. So what do I have to do with this graph to get to the second derivative? Take the slope of it. So the slope of this graph is positive here and negative here. That means the second derivative is positive here and negative here. So doesn't that make that a point of inflection? So x equals 1, 2, 3. And if you looked at like those cheat sheets I made, there's like that might help you too. If you have a derivative graph, points of inflection are the maxes and the mins, the peaks and valleys, because that's when your slope is changing. So the slope of the derivative is changing. That means the second derivative is changing. So -3, -1, and 3. So the derivative changes from what to what? Not positive to negative. Increasing to decreasing or decreasing to increasing. -2, like here. So you're looking at like that's a point of inflection of this graph. So points of inflection are 2 levels down from the graph you're looking at. So we're at the first derivative. If I look at a point of inflection on this actual graph, I'm at the third derivative. Third derivative is actually called jerk. So it's like a change in so velocity is your change in distance. Acceleration is your change in velocity. Jerk is your change in acceleration. So think about if like you get jerked on a roller coaster or a car. Like I was explaining, it was explained to me like jerk is what spills your coffee. Like if you're riding a car and someone like really changes the acceleration, that's what you, does that make sense? Does that make sense why it's not those points though? If this were F, those would be the 2 inflection points, yes. Where does F, let's say wait. We good? Where does F achieve its maximum on the interval 1 to 4? So 1 to 4 is here. What's true about F prime in that entire region? Be careful. F prime is not increasing over that entire region. Positive. F prime is positive, which means F is increasing. And so if F is increasing this entire time, where is it the big? It's going to be at the end, which is x equals 4. They didn't ask you to explain that, but if you did, you would just say because F is increasing over the entire interval. So the thing I'm noticing, just like, I don't know if you're just not like thinking when I ask answers, but some of you are kind of getting mixed up with the increasing and positive. So just be really careful about those words. If I say something is increasing, I'm actually talking about the slope of it. Right? For something to be getting bigger, it's got a positive slope. So if you say increasing, you're essentially taking the derivative because you're talking about the slope. If you say decreasing, then you're saying it's getting smaller, so you're talking about the slope. So you're essentially taking a derivative with that word. Like the words increase and decrease are derivatives, basically, because you're talking about the slope. Does that kind of make sense? Let's keep going. Let's see how we do. So try that. These are not free responses. That's okay. Try those next 2. This is F prime. Yeah, because it says over here the derivative of that. Like there's a, yeah, they're asking you about F, but they're showing you F prime. Don't say it. Like I don't know what you mean. What about the slope? You know. No, I'm getting ready for your language. Yes. Cussing in front of everybody. Hilarious. I go down to Mr. Gill. I'm sorry. They won't stop saying gay in class. Devin keeps cussing. What's he saying? The F word? No. The S word? No. The I word. Is 13? 13 or 17? 13, 1 is not right. So at -3, what is the value of the derivative? 0. So what's the slope of the original? 0. So that's a horizontal tangent. But at x equals 2, what's the value of the derivative? 1. So what's the slope of the original? Is 1, which is not horizontal. You just had a moment? All of it. I can't believe you're still cussing. I just understood all of calculus. The thing. Yes. You can say the word it if it's not referring to a function. Try what if we had to go through your day without saying the or something? Is what? 13 is D. Is it okay if I answer instead of Jack? I'm not saying Jack can't answer. He seems busy. Still cussing, though. A lot. Okay, say your sentence again, then. Okay, so that's mathematically incorrect because you said if we're below the axis, we're decreasing. So if the graph of f prime is below the axis, what does that mean about f prime? Negative. Which means what about f? Yeah. So if you're using it to refer to f prime, you're doing the math wrong. If you're doing it to refer to f, you're cussing up a storm. So, yeah, I'm sorry, Delaney. I interrupted like All right, so let's talk through these. Give me actually, I'll ask this after I go through these. Okay, so this is the derivative. An x equals -3 and x equals 2, there are horizontal tangents. The first thing I notice is those are not, well, no, they kind of are. Okay, never mind. Well, I was going to say, one's an x-intercept and one's not, so that kind of clues me in that there's different things going on. But they both have a slope of 0, so I can see how you could think they were the same also. So at -3, what is the value of f prime? 0. The y value of f prime is 0, which means the slope of f is 0, which means horizontal, right? So this is horizontal on f. Here, what's the value of the derivative? It's 1. So what's the slope of the original graph right there? 1, and that's not horizontal. This is not true. -3 is fine, but 2 is not. Number 2, where x equals 1, there's a relative min. Okay, so I need to know whether f is increasing or decreasing. It's a do that, I look at whether the derivative is above or below the axis. So down here, or over in this region, f is decreasing because f prime is below the axis. Here, f is increasing because f prime is above the axis. So if I switch from decreasing to increasing at that spot right there, do I get a relative min? I do. Sounds good. And then at x equals -3, there's an inflection point. So you might start to kind of memorize on derivative graphs, inflection points happen on the original, where there's peaks and valleys. So it is going to be. Some of you, again, just thinking through the process is better. So this, I want to know if inflection points come from the second derivative. I'm looking at the first derivative. So to get to the second derivative in my mind, I've got to take the slope of this. So does the slope of this switch from positive to negative or negative to positive at -3? And it does, right? Because we go from positive slope to negative. So that was true also, so that one is true. Questions on before I slide up? Alright, 17. Again, we got a graph of f prime. F is increasing on the interval -2 and -1. They want you to look at this. Think that because this graph is getting smaller, that f is not increasing. Hopefully, we know that this graph is the derivative, and this graph is above the axis between -2 and -1. So the original graph is increasing during that spot. 2f has an inflection point at x equals 0. So again, inflection points come from the second derivative. So to get to the second derivative from what I'm looking at, I gotta take the slope. So the slope prior to x equals 0 is negative. The slope after x equals 0 is positive. So it does switch there. And that is a point of inflection. And then number 3, f is concave up between -1 and 0. What level does concavity come from? The second. I'm looking at the first. So how do I go down a level? Take the slope. So the slope of this between -1 and 0 is negative, which does not match up with concave up. We want it to be positive for it to match up. So it's 1 and 2. So that's D. Question on that one I can answer? So here's what I was going to ask a second ago. 5 means, you already know what I'm saying. 5 means I'm totally with you. This is easy. I got this. 1 means I don't have a clue what you're talking about ever. 3's in the middle. Flip me off. Okay. Thank you. Nobody put a 0. That's a good sign. Try the next 3. Oh, I saw your fingers like that. 4.23. Again, if you want to have that sheet out, I think it's helpful to do the problems. I think it's going to be helpful to kind of get you to understanding it. You just want to not rely on it. Positive. ask you, so this is rich prime, right?
Yeah.
So I want the original. Here, the original graph is so you got it. You can see that. So what does what's F prime? Because you're switching. Like here is the after that's yeah. Positive slope of the derivative is correct. Basically, since this is F prime, and you want to find the concavity, the one you got gave up, you take the slope. Yes. Well, you know the slope is positive. That graph is increasing. Right. Notice the slope increasing. The slope's increasing and then curving. Okay. Wait, so it's only going to give up in the other x-axis? No, sorry. Yeah, but you're just saying it. You're pointing at it, right? So this is the positive slope, right? And that's what you're looking for. This is also increasing, but this is not an increasing slope. Okay. So positive slope looks like this. Increasing slope. Increasing looks like this. Increasing slope. Now you're telling me. Okay. So I just want to say or increasing right there. Yes. Or positive slope. Okay. Alright. So your concept was right, just right. Yeah. So this is the original. So if the derivative is 0, what is that? The second derivative is 0, what is that? The second derivative is 0. I don't know. That's a part of the function. This is nonsense. The slope from 6 to 8 is 10. So be careful they go back to. So it's actually 2.5. Either way, like, would I use the slope from 6 to 8 or the slope from 8 to 10? It should be in between. So, like, this is the slope. 6 to 8 is 5 usually, right? So it's good, right? 5 to 2, and this is 10. So if it's 5, here, look at that. So if it's 5 here and 10 there, it's got to like gradually increase. It must be between 5 and 10. Alright, let me go through these three. Do you guys want more time or are we good? Raise your hand if you'd like more time. People are still talking though, but I don't know if you're done. People are still working, but nobody wants more time. Bud, you good? Okay. Alright. Alright, so f of x greater than 0 means, so I'm looking at f, saying when is f bigger than 0, so that's just like where the y value is positive. Which one does that eliminate? N. Alright, f prime of x is less than 0, so that means the derivative is negative. Derivative negative means what's true about the slope on here. Careful, no. Slope is negative. or the graph is decreasing. If you say slope is decreasing, that's concave down.
Don't say that.
Slope is negative. So what does that eliminate? P and Q. And then F double prime is less than 0. So this, if you say slope decreasing, that's what you're telling me. Slope decreasing means your slope is getting smaller as you go. That's concave down. So just be careful with your, I think there's a lot of people that are at the point where you understand it, but you're not sure quite how to word it yet. So just be careful with your wording. So I want a concave down. So remember, concave up is like the U, is U for up, and then concave down is like the N, like N down, I guess. So which one of those does that eliminate? M, because that's part of the U. So your answer is R, which is E. How many have that? Nice. Yeah.
How come it's not Q again?
Q, because the slope at Q is 0.
Okay.
Not less than 0.
Yeah, that makes sense.
So let's go through, let's say like right here, at this point, N, is f of x positive or negative? Negative. Is f prime of x positive or negative? F prime of x is positive, right? Because the slope is positive. Is f double prime of x positive or negative? Is that an inflection point? Here, let's make a different point. Let's use this one. I think it's a little clearer. F of x, positive, negative, or 0? 0. F prime of x, positive, negative, or 0? Negative. F double prime, positive, negative, or 0? Positive, because we're concave up. Is f prime increasing or decreasing? F prime, increasing or decreasing? Yes. So f prime is increasing. Two ways to think about that. One is it's concave up. That's what f prime increasing means. Or f prime means slope, right? Isn't your slope increasing? So like, what's the slope here? It's very negative. What's the slope there? Less negative. If your bank account goes from very negative to less negative, didn't it increase? You're still in a crappy situation, but it increased. Okay, number 9. This is the derivative. So, what is above the axis mean here? About the original? Increasing. What is below the axis mean? Decreasing. So f is decreasing at x equals 0 is false. Because at x equals 0, what's the slope of the original graph? 1. And is the slope of 1 decreasing? No. F has a local max at x equals 2. Well, at a local max, we want it to look like that on f. So we want f to go from increasing to decreasing, which means we want f prime to switch from what to what? Positive to negative. Right? Don't these mean the same thing? So I want f prime to switch from positive to negative. Does that happen at x equals 2? It does. And then f is concave up at x equals negative 1. So concave up means f double prime is positive, which means like the derivative of the derivative is positive. That's not really the way I'd write it, but I'm trying to say like the derivative of the, does that make sense? Like the derivative of the derivative is the second derivative. So what is the derivative of this graph? What do I do to take the derivative of a graph? Let's look at the slope. Is the slope of this graph positive to represent up when x equals negative 1? It is. It is. Yeah, it is. So it is positive. So 2 and 3 are both true. How many I did it? Nice. 24. So if g prime of x equals 0, what does that tell us about g? Flat, horizontal tangent, slope is 0, those are all good. So all that's left is b double prime is positive, what does that tell us? Concave up. G double prime is negative. Down. So G double prime is 0 is where it switches. So it's a point of inflection. Because there, what's true about the second derivative? Now you just took the fourth derivative. Second derivative is positive, which means f is concave. Yes. I'm just making sure we're speaking the same language. Any questions on this page here? Alright, try the next one. Got a bunch of true false there for you. I don't know what the fourth derivative is. It'd be like the change in jerk, but like that gets a little bit too much for my brain to process what that means. So jerk is change in acceleration. Fourth derivative would be the change in the acceleration, which like I'm sure exists, but I can't like process what that would mean in real life. That's like the hardest one. Here's where I'm stopping. Here's where I turn around. I'm still going back. Okay, so that's yeah, that's it. Yeah. Right, right. That's a relative max. Because the original graph goes
Right.
yes. So that's a relative max.
Exactly, which is right here.
Okay, but a relative max on this graph.
Oh, not
So
the
that's
original graph.
yeah.
Oh, okay.
So maybe I should. So we're so that's not
Right.
but again, I'm
This is the first.
so this is supposed to represent like which graph are you looking at?
Okay, what is this?
You're looking at the slope of the
Well, we don't have that graph. Okay, which is graph here and add this graph. So it's 1 and negative 1.
I came up.
I did look at that.
Stop! Cussing. Stop saying it.
This is the slope of that.
This is above the axis. You use F prime to tell you what F prime of x is decreasing. So you're literally just you're looking at F prime. So just tell me is the graph that you're looking at decreasing.
Oh, I thought that was the point.
Oh, like negative 1.
Yeah.
So I didn't put any y-values.
So what's 25? That's true.
I thought it was. I thought you meant at negative 1. So it's not negative 1.
So if I say on, that means like on an interval.
Okay.
That's just the way it's
Don't
out.
you like? Aren't you supposed to put the bars down?
Well, that's different because then I'd have to then I'd make sure I'd be including negative 1 and 1. And this graph this means in between but not including those. So I can't put brackets because this graph is not really decreasing in negative 1 because it's flat.
So I thought you meant a point. That's why I thought it was.
That's fine. I'm just trying to help you.
Yeah.
But it's true because like slope's negative.
Yeah.
So like you're asked about F prime, and you're looking at F prime. So you literally just tell me if what you're looking at is decreasing.
Oh, okay. Yeah.
Alright, we'll go through these. Make sure you get all those done. Let's take your homework and 8 questions. We'll go through them tomorrow.
The text equals 2.